Hello everyone, welcome to Computer Aided Analysis Laboratory. I am Rakesh VALASA. In this video lecture, I am going to explain how to solve the experiment 2.1 in ANSYS 19.2 Mechanical APDL on Windows 10 platform. Here the name of the job is stepped bar. The objective of the experiment 2.1 is to determine nodal displacements, stress, strain and reaction forces. Here the given diagram having two elements. First element length is 2 meters, second element length is 4 meters, and one end both ends are fixed, and each element having two nodes. We know that. So first node coordinates are 0 comma 0, second node coordinates are 2 comma 0, third coordinate nodes are 2 plus 4, that is 6 comma 0. Here the force 10 power 5 newtons acting at node 2. Here one more given data is given, that is element 1 area is 1000 millimeter square, element 2 area is 500 mm square, element 1 Young's modulus, that is 200 GPa, and second element Young's modulus is 100 GPa. You need to convert those units in terms of meter square. You know that 1 millimeter equal to 10 power minus 3 meters. So 1000 into 10 power minus 3 whole square. Here 200 into 10 power 3 Newton per mm square. So you can convert into Newton per meter square, that is 200 into e power 9 Newton per meter square. Okay, now open ANSYS 19.2 software. Now click on start button and choose 19.2. In that you have to choose ANSYS Mechanical APDL 19.2, or you can also choose Mechanical APDL product launcher. Here I am choosing Mechanical APDL 19.2. Okay, now the software is launching. It takes a few seconds. Okay, now the software is opened. Now maximize this window. Generally we know that a few important options, that is go to the uh, utility menu and choose file. First one is clear and start new. In that you need to choose do not read file, then click on OK. The second important one is go to the file and change job name. Here job name is, we know that, stepped bar. Job name is stepped bar. Now click on OK. The third important one is file change title. In that you have to enter, you have to type static analysis. Static analysis. Now click on OK. In the main menu, it having many options are there. In that we are using preferences, pre-processor, solution, general post process. These four steps are very important to solve the given stepped bar in ANSYS mechanical APDL software. First one is preferences. In that choose structural, then click on OK. The second one, pre-processor. In that element type, add or delete, add or edit or delete. Now click on add. In that you have to choose link 3D Finite STN180, then click on OK. Now close this window. Next one, go to the sections. In that click on link. Now click add. Now enter add link section, that is 1. Now click on OK. Now section name is also 1. Here the section data link area is, we know that, that is A1 equal to 1000 mm square. Now convert into meter square, that is 1000 e minus 6, because 1 millimeter equal to 10 power minus 3. So meter squares, mm square, 10 power minus 3 whole square, that equal to 10 power minus 6. So you can type 1000 e power e minus 6. Okay. Next one. Now again click add. Uh, Add link section with ID, that is 2. Now click on OK. Section name is 2. Second element area is 500 millimeter square. So 500 e minus 6. That is, now click on OK. The next step is go to the material properties, that is above section. Material properties, material models, structural, linear, elastic, isotropic. Now enter the element 1 Young's modulus, that is 200 gigapascal. Now convert into Newton per meter square, that is E9. Poisson ratio 0.3. Now click on OK. Now create one more material. Go to this menu bar, material, new model, define metal ID is 2. Now click on OK. Elastic, isotropic, enter the new model Young's modulus, that is 100 GPa, so that is 100 E9 Newton per meter square, Poisson ratio 0.3, then click on OK. Now close this window. The next step is modeling, create nodes, inactive CS, node number 1, first node starting point is 0, so no need to enter y0 z0, then click on apply. Next, node number 2, second node x value is 2, y0 z0, now click on apply. Node number 3, 2 plus 4, that is 6, y0 z0, now click on OK. Now nodes are created. If you have any doubt, you can go to the utility menu, click list and choose nodes. One window is open, that is, in that you have to choose coordinates only, then click on OK. You can see these values: 0 0 0 first coordinate, second node 2 0 0, third node 6 comma 0 comma 0. Now close this window. Next one, modeling elements, element attributes. This step is very important for solving stepped bar, because both elements having different cross-sectional areas, different Young's modulus, so that's why master should be focused on this step. Element type number, this is okay, common to two elements. Material number 1. Next, section number 1 okay. Now auto number, throw nodes, join 1 and 2. Now click on OK. This second step is also most important. Go to the element attributes. Must and should change 1 to 2, because element 2 having Young's modulus 100 GPa. That's why must and should select 2, and section number 2 because section 2 area is 500 millimeter square. So that's why must and should choose material number 2, section number 2. This is the most important step for this problem. Now click on OK. Auto number, throw nodes, join 2 and 3, then click on OK. The next step is after this you should apply the boundary conditions. Here node 1 and node 3 both are fixed with respect to all degrees of freedom. So go to the loads. Just scroll down. Loads, analysis type, new analysis, static analysis, then click on OK. Next, define loads. Apply the loads, apply the nodes, structural displacement on nodes. Here, in the given problem, first node and third node both are fixed with respect to all directions. So choose first node and third node, then click on OK. Here, DOF is choose all DOF, all degree of freedom, then click on OK. The next step is apply the force or moment on nodes. Here the load is applied at node number 2. So choose node number 2. OK. That force is acting towards right side, so in x direction. So no need to change fx. Here enter. That force is acting towards right side, so positive value, that is 10 e power 5. 10 e power 5. 10 e5. 10 e5 newtons towards right side direction. Then click on OK. Now capture this image. Go to the report generator. Append OK. Yes. Now capture this image. This is the boundary conditions for the stepped bar. Stepped bar with boundary conditions. Then click on OK. You can also change plot controls. Uh, Plot control style, size and shape. You can convert into 3D image. Display of element is turn on. Now click on OK. Go to the plot elements. You can see in the isometric view, that is depending upon you. Front view. The next one is solution. Next step is very important, that is solution. Solution, solve current ls. OK. So now the solution is done. Now close this window. Next, move to the general post processor. Here, general post processor. In that, choose plot results, contour plot, nodal solutions, DOIP solutions. Now click on OK. Nodal solution, X component. Now click on OK. You can see here. Now capture this image. Nodal solutions. Nodal solutions. Now click on OK. The next one is, you can also capture deformed shape, deformed place, undeformed shape. OK. Now also you can capture this image, deformed shape, deformed shape. You can also create element table. Go to the element table, scroll down, element table, define table, click on add. First one is force, scroll down by sequence number, SMIC, 1, apply. Second one stress by sequence number, LS, 1, apply. Third one strain, scroll down, choose by sequence number, LEPL, 1. OK. Now close this window. Next, move to the plot results. Contour plot, line element results. Here choose force. OK. Now capture this image. This is the force. OK. Now again choose element, line element results. Node 1 stress, node J stress. OK. Now capture this image. This is the stress. Now click on OK. Now again click line element results, strain, strain, click on OK. Now capture this image. This is the strain. OK. Now next move to the list results. Element table data. Now choose these three options: force, stress, strain. Now click on OK. You can write this data in LMRB. Force at force for element 1, element 2, stress for element 1, element 2, strain for element 1, element 2. Now now go to the report generation. Click on HTML report assembler. Report heading. Here the title is static analysis. Static analysis. Author name. Type your name. Here my name is Rakesh. Subtitle, that is stepped bar. Stepped bar. Okay. Now add those images to in the right side. Okay, add all those images in the right side. Now click on preview report. Okay, due to compatible issue, it is not opening. Direct you can go to your folder ansys 2024 folder. Open stepped bar report. In that HTML document, okay, now click Control P. Destination Microsoft print to PDF. Now click on print. Okay, save in your specified drive. Then click on save. Okay, now close this window. Plot controls, animate, mode shape. You can see the animation for the given problem. We know that in the given problem, first node and third node both are fixed with respect to all degree of freedom. Only the force is acting at element 1, that means node 2. So here the deformation occurs only in between these two elements. You can see this one. Stop and close this window. Okay, this is the solution for the given. This is the solution for the given problem. How to solve the given stepped bar problem in ANSYS 19.2 mechanical APDL. I hope this solution is very clear to everyone. You can also see the steps in your LMRB. Okay, you need to take these printouts for submission of your LMRB. Thank you for watching. Please do like and subscribe my channel for more updates. Have a nice day.